Okay, so we're gonna go back to trig. Oh boy, do you remember some of the basics? Like, do you know when I say pi, what is pi? Pi is 180 degrees. So that's pretty a big deal, right? What is a whole circle?
2 pi.
2 pi is a whole circle. So that's another big number to know. And what was the top? What would be a 90 degree? Pi over 2. 3 pi over 2 is 270. Okay? You have your unit circle with you. You will have that on the exam. Do you see how everything else goes? Okay, so draw this angle in standard position. So first of all, what does negative mean in an angle? You're dropping. You're going backwards. Okay, would this make sense if I said 7/8 is pretty close to 8/8? 8/8 is a full pi. So we should do less than a full pi. I went 7/8 of a full pi. Does that make sense of my strategy there? State a positive coterminal angle. So I'm going to take the angle that I have. What does coterminal mean to you again? Do you remember that word? It's going to land in the same spot. So look at me. I'm facing Oakley, and I can do this. One circle, and I'm facing him again. So I added a circle. So what if I add a circle? It's like adding a 2 pi to it, right? Can we revamp 2 to match this fraction? So this fraction has an 8 on the bottom, so can you change the number 2 to be 16 over 8? So that makes 9 pi over 8. Okay, coterminal, rotate a circle. And then I had a question that was like, state all the coterminals up to this amount. Remember those questions as well? Okay, arc length, this is on your formula sheet. We've probably never even looked at it on our formula sheet because most of you had it memorized. That is on your formula sheet. So S is the arc length. So we're trying to find that. What do you always know about the angle when you use this formula? It has to be in radians. So 130 degrees, I'm going to convert it to radians. Okay, I'm going to give you a multiple choice here. Should I times it by 180 over pi or pi over 180? Times it by pi and divide it by 180 because you can see that the degrees are going out. If you divide by degrees, the degrees would go. So this should be typed into your calculator all in one step and then always 3 decimals. That's always the rule with our whole course. And also there'd have to be units on there because I would have to deduct you some kind of communication error. Did anybody match me? Yeah. Yep, okay. Okay, XYR ratios. If an angle terminates in quadrant 2, so you better know your quadrants. it told me the cosecant theta ratio. So again, this is additional nice version of me. I gave you these formulas on your formula sheet, which was an add-on. So you can look on the back. What letters is this? X, Y, R?
R over Y.
That's an R over a Y. So I'm going to put that there and that there. So how do I get that? Be a Pythagorean theorem backwards, right? 3 squared subtract a 2 squared in my 9 subtract 4 equals 5. Would that square root nicely? No. When you see exact value, there should be 0 decimals. I can't move that to a decimal, so I'm going to just leave it as a root 5. Okay, when you are doing trig, here's the number 1 rule. You ready? Don't put negatives in your math. Put negatives into your drawings and locations, right? So what do you know? So 3 is a radius. That's positive. 2 is a y. That is positive. Root 5 is an x. It is negative because of its location, right? Do you see it? Quadrant 2 is negative positive. So tan theta equals formula sheet. What letter divided by what letter on the formula sheet? Y over x. Okay, exact values from the unit circle. So how do we get to an 11 pi over 3? It's not on our sheet because it's me doing a bunch of circles right now. Okay, would we agree that that is 3 over 3 pi? Right, because it's 1 pi, so that's 3 over 3. A full circle is 2 pi, so that's 6 over 3. Should I keep going? 9 over 3. So the next would be 12 over 3. So I'm in this quadrant. So what's the angle that you're looking at? You're looking at 5 pi over 3. Okay, that's where you look. And sine. Sine is the what letter? What letter is sine? Y over R. Guess what R is on the unit circle? 1. It's irrelevant to us. So I want the Y value then. Just the Y. That's it. So look, get me the Y. Negative root 3 over 2. The Y value. When I look there, what is the Y value? Okay, 4 pi over 3. Are you looking here? You're looking here. Secant. What do I do with letters with secant? R over x. Okay, forget R for a second. I don't care about the R's right now because they're 1. But I don't write x. What do I do with x? Flip it. I take x and flip it. Because secant is the flip of the cos, remember? So look and flip. Okay, negative 5 pi over 6. So where are you looking? you should be looking at 7 pi over 6, right? Tan, letters. Y divided by x, right? Sorry, you can't cancel anything out there, right? I need the y and I need the x. It's only the r that it's irrelevant, right? Because the r is 1. So y divided by x. Okay, that was good. We're going to solve it or evaluate it now. Who can tell me if my answer is positive or negative at the very end? Positive. 4 negs make a positive. So I had multiplying and dividing with 4 negatives. This is going to be positive. Okay, so forget the positives now, or forget the signs. Are we okay on this if I tell you that the 2's would disappear with the times and flip of that system? That will always happen with tans like that. Okay, they cancel on the flip. That's good. Okay, what else here? I'm going to multiply now. Root 3. Top, bottom, cancel. Oh, there's a 2, top, bottom, cancel. So what is my final number? The answer to this is 1. Okay, so that had a lot going on. We had to learn how to do recognition of angles. All those letters are coming back. Okay, solve for this angle. Okay, I think I gave everybody a bright pink paper on this unit. So there's always steps. Your first step is algebra. Can you isolate something here? No, because you have 2 variables. The second step would be boom, equals 0. You got to make sure it equals 0, which is already done. Third step, let's ask ourselves if it factors. Do I recognize the style? So in my brain, I'm going to go through, is it a GCF, differences, squares, simple trinomial, complex trinomial? And what did you come up with? Simple. So tan theta, what multiplies to 4 and adds to 5? So 1 times 4. So tan theta equals 1, tan theta equals 4. All you've solved for is called the trig value. You have not figured out any angles. So algebra gets you the trig values. Okay? Do not stop, because you would get 1 out of 5 points. So don't do that. Okay, I'm going to figure out the angle, and it says for all angles. We are going to do this in radians, because radians is what I would do unless it specifies, like here, that's a specifying out of radians. Okay, can you tell me what quadrant this angle would end up in? So now, what are you remembering? Astica. Look at all these things coming back into your brain. Astica. Tan is positive. 1 and 3. So there's my angles. They're in those 2 quadrants. This is a unit circle. We can get this one from the unit circle. What is tan again? How do you get that with the letters? Y over x. Is there anywhere on a unit circle where I would divide y and x and then it would make a 1? Right here, right? And right here. So some of you might have just answered me a decimal. I would mark it right, but this is impressive when you can remember these things. Okay, I'm not done because it says all real. So you can do this plus 2 pi k kei on both of these. That's acceptable, that's good. I will tell you one other option. Would you make sense if I took this angle and rotated just 1 pi? It would include that answer. And rotating a pi, rotate a pi, rotate just a pi's includes all those. So this answer is great. This answer is also great. Okay, this one's a little more impressive because you thought about something different, right? Okay. Tan theta equals 4. So what quadrant? Astica. If the angle has a positive trig value for tan, we are in quadrant 1 and 3 again. So this one is not unit circle related. So I have to go to my calculator. So what are you doing in your calculator? We want to get an angle, so that's the inverse. So we're tan inversing 4, and then we're also making sure what? We're in radian at the top. Remember that. Okay, so that number I got was 1.326. How would you get this location? Plus, it's bigger than pi. It's that much bigger than pi. Do you remember that? So 4.467. Okay? So in this quadrant, you're less than pi. In this quadrant, you're less than 2 pi. So plus 2 pi k okay, also you could have just written it with 1 pi rotations as well. Is that coming back to you, all that kind of stuff? No.
Or could you just do the equation?
You could just do this,
Okay.
yeah, and be done. I did want to just practice that though, so. Okay, the next one, are we understanding the algebra? We cannot isolate here. We have two variables again. Equals 0, check. Does it factor? Would be my next. I kind of don't think it does. If I flow this, I get a 2. Is there any multiples of 2 that can add to 5? No. So I know some of you would probably say this is unsolvable and write me a lovely little message. What else could we do though? The formula, there it is. Formula. Okay, oh, no, no, I have to backtrack. I did this last year too. I missed something. This is, sorry, different type of question. I did this last year too. I gotta read my questions. There it is. Here's my problem. There's my problem. There's sine squareds and coses. That's a problem. I can't put that all in a formula. Okay? What can we do then? We have to do a substitution. We have to do a substitution. Which one of these could you make a substitution for? Sine squared. So this is in the front of your booklet or of your formula sheet. Top corner, what can you replace sine squared with? Those little identities, we called them. 1 minus cos squared. Okay, identity substitution. Now, okay, so did you recognize that? Make that substitution so that everything looking forward is in cos stuff. So I'm going to go distribution to that. This is just algebra stuff. So now I had a 2 at the start and a 1 at the back, so they're 3 together. Okay. Personal preference, I don't factor with negative leaders. I don't want that. So would you be okay if I'm telling you I'm timesing this equation by -1 across the board? Does that make sense? Okay, now I'm going to recheck. Does it factor? Now it will, okay? I probably should have put one on there where we are practicing the quadratic formula. So if it doesn't factor, you have that formula, right? So 2 cos theta and a 1 cos theta. Okay, where do you want to put the 3 and the 1 to make sure FOIL works out? To make sure we make -6, +1. Does your FOIL work out when you get your factors lined up? Okay, cos theta equals, boom, a trig value. This is a trig value. Did you write -1/2? Okay, I'm going to do this one because it's easy. No solution to it. Greater than. Cos and sine can't go out of that 1 or -1. If you forget, don't worry, you'll discover it because once you cos inverse 3, error. This is in what quadrant as a solution? Cos negative. Left A half is an x value that is on my unit circle, so I am not going to touch my calculator. Where is x negative a half? 120 degrees and 240 degrees. Where is x negative a half? Those two. But we better go back here. In my solution, my angle has to be in this domain. We have to fit this domain, so what do you know? You can't have 120 degrees as a solution anyway. Okay, I'm sorry, I just want to do something super quick on the side here. Can you solve this for me, just to make sure we know how to use our calculator? In radians, from 0 to 2 pi, that would be my domain. Can you figure out the answer to that? Okay, so first of all, you should be drawing bottom quadrants. Next, you're grabbing your calculator. Rad mode, radians. Okay, we are going to sine inverse in our calculators. Brackets, what do you know about typing? Don't put the negative in there. Do sine inverse of 1/3. And then I got 0.3398. So that's not my answer. That is considered a reference amount. So that's how far you are away from the axis. So how would you ever get this number? Pi plus that, right? Because you're more than the pi. And then the other number, what would you do to get that? 2 pi minus that distance, right? Ask yourself if your answer makes sense, because you know a whole circle is around 6.28, right? That's a circle in radians. Okay, so I just wanted to make sure you remembered those calculator steps